Yeah.
The only thing that's going to be on the test.
Yeah, 4:1 and 4:2 are not going to be on the test.
The test is just
Chapter 3 and proofs. It's the proofs. And I promise you, I'm going to write up a nice little review, and I'm going to tell you, I'm not going to probably write any new proofs, but the proofs that we've done, they're going to be so similar. You just have to go through them. All right, I promise you, it's good. All right. Now today we're just doing some classifying. The next chapter is all about triangles. All right, and lots of interesting things about triangles. Classifying a triangle as acute, equiangular, obtuse, or right. And obviously, I think everybody here knows acute means all angles are less than 90. Now, equiangular means that all sides equal what? Or all angles, equal what? 60 degrees. All right, in a triangle, their equiangular is all angles are 60 degrees, especially because we know, right, well, we know, and that's actually how they figured out, kind of that's the proof behind that, but the angles of a triangle add up to what? 180. And if there's three angles, 180 divided by 3 is what? 60. So that's how you know that. All right? We're going to, yes.
Oh my God.
Obtuse. Obtuse now just means that one angle, though, all right, is greater than 90. All right? And only one angle is greater than 90. All right? And then, of course, you have a right triangle in which one angle is what? 90 degrees. All right. So question number 1, that is what? Equiangular. Number 2, that is obtuse. Number 3, number 4, acute. Number 5 and 6, acute. Easy as that. All right. Now, the next one, we have equilateral. That just means all sides are what? Now, here is something, if I was writing geometry, I would change this. And I think I've seen this once before on the SAT, this knowledge that is an equilateral triangle isosceles. I would say no, but guess what? It is, right? Because the definition of isosceles, listen to me, the definition of isosceles is at least two sides are congruent. All right? So again, every equilateral triangle is also what? Now again, that could be a good true and false question also on the test. All right? And if you're not careful, personally, I wish they would just say equilateral means all sides are equal, and isosceles, two sides equal. But again, that's not the definition. All right? The definition of isosceles is at least two sides. All right? So every time you write equilateral, you're supposed to also write what? Isosceles. But I'm not making you do that. I want the definition to be equilateral, all three sides, isosceles 2, and scalene what? No sides are equal. All right? Is everybody with me on this? All right? So again, on a true and false test, though, they might say an equilateral triangle is also isosceles. And you would say what? You would say true, because the definition of isosceles is at least two sides. All right? But again, when they say, what is this, and it's equilateral, I don't want you to write equilateral, comma, isosceles. All right, is everybody with me? All right? So let's take a look. ABE. What is ABE? I think it is, so again, identify quickly. Scalene. All sides are different. All right? E, B, and D. Definitely isosceles. EBC. EBC. Very good. Scalene. And DBC is equilateral. All right, definitely equilateral. All right. Now, it says for number 11, find x and the length of each side if ABC is an isosceles triangle with AB congruent to BC. Bless you. So if AB is equal to BC, you should be able to just look at that, please, and tell me that X equals what? Practice your mental math. X equals what? 4. Right? Practice your mental math. You're just simply saying 4x minus 3 equals 2x plus 5. Everybody good with that? So x equals 4. Now we have to find the length of each side. So AB would be what? 13. And CB would automatically have to be. And then AC is? Okay. 6. Everybody good with that, guys? Any questions? All right. So again, practicing our mental math. It says here, if it's equilateral, which would be the easiest to compare? It doesn't matter, but I would choose GH and FH. Yeah, just X is 1, right? So X equals what? Does everybody agree? X equals 9, right? And if X equals 9, then each side is what? Good. 37, 37, and 37. All right? Now, that's a good way to double check your work. If you plug 9 in, you'll see that all sides are 37. Everybody good with that? All right. So here we go. 13. RS is congruent to TS. So practicing your mental math again. What do we got? X equals what? So they agree with that? X equals 2?
Yep.
Everybody looking at that? X equals 2, right? Okay, now each side, 20, 20, then what? So far, so good? All right, so now, here we go. All right, for 14, what do I got? It's an equilateral, right? So find the easiest one to compare, which is what? So again, please, just practice. Don't just write down X equals 9. All right, some of you are excellent, some of you aren't. So double check yourself that you're practicing for X equals 9. Is everybody good? Chandler, you all right with that? All right. So now give me the sides. I don't know why I said that, Chancellor. I'm sorry. I'm delirious today. What is it? DE is what? 24. So they're all what? All right, now I understand what you guys are trying to tell me. All right, very good. Thank you, Chandler. All right, I don't know what I'm doing. All right, 24. What?
It wasn't his birthday. That's why we're all laughing. His birthday is September 2nd, not October. I didn't know that because he said.
What's said? It said in the.
They probably messed up September.
Yeah, because it couldn't have been mine. All right, here we go. All right, thank you for that. Wow, that was. And because it was off. Does your brother have a birthday this month, or was this last month? All right, here we go. So roll all the way around. Okay. All right, now let's flip over to the next page because we got a few more minutes, and I want to show you that page was simple. Now, this page down here where I want to show you how to do 10, 11, and 12 real quick. All right, this is the only one that's kind of annoying. So what I want to do is, that was so bad. All right, so here we go. 10. All right, now again, what I want to do is we're going to graph. Again, I just think it's easier to graph because I prefer doing the Pythagorean theorem rather than doing the distance formula because to me it's just easy to visualize that. All right, we are classifying. So what we have to do is let's make ourselves an X and Y axis, please. X and Y axis. All right, and let's plot -3, 2. and then 2, 1. And then we're looking at -2, -3. And then we're graphing. Okay, so now, again, here is what I would like for you to be able to do. All right, I would like for you to be able to, and I'm going to show you what I'm doing first, and then we'll see if we can do it mentally here. This right here is the right triangle. Does everybody agree? That goes with, that corresponds to those 2 points. Does everybody agree?
What are you doing?
I just made a right triangle.
Okay, yeah.
You look down that or not? Okay, so now just watch. All right, learn something here. All right? So this distance from here to here is 1. And this distance from here to here is 5. So this right here is the square root of 26. That's what I would like for you to be able to do. You can use the form. Come on now.
We already learned this.
Like, well, what's the matter? Seriously.
Okay.
What?
Nothing. I didn't.
All right, it's a right triangle. That's all we're doing. All right? So now I'm trying to find this length right here. All right? Now again, we're just drawing out the right triangle. But I would kind of like you to visualize the triangle and say this from here to here and from here to here. That's what we're looking at. Does everybody agree with that? So this is 1, 2, 3, 4. And this is what? 1, 2, 3, 4. Is everybody with me on that? So because we are brilliant, 4 squared plus 4 squared is... Now listen, here's how I want you to think about this right here. Look right here. All right? So you're saying it's the square root of 16 plus 16. Is everybody happy with that?
Yeah.
Now listen to what I'm trying to tell you. All right, I think this is a smart way to think about this. Listen, 16 plus 16, I don't want you to say it's 32. I want you to say that there are 2 16s there. Everybody agree with that? Listen, I'm just trying to show you a different way of thinking about numbers. Right? If I say 16 plus 16, I'm asking you, do you agree that there are 2 16s there? Now, why do I do that? Because that will be a perfect square. So what's the square root of 16? 4 radical 2. All right? Now, if you do 32, you just have to break 32 down to what? 16 times 2 anyway. All right? So what I'm trying to show you is that when you square, you end up with the same number for an isosceles triangle. There's always a radical 2 involved. All right? So I'd want you to know this side right here is 4 radical 2. All right. Now, what I want to do is I want to find the last one here. Here's this right triangle for the last side. And then you should be able to tell me this is what length here? 1, 1, 2, 3, 4, 5. So that again is the what? Square root of 26. Right? So you know it is what? Isosceles. All right? All of that so you can spell isosceles. Anybody have any questions? All right, here we go. So now all I need you to do, please, just finish up. All right, just finish up. Honestly, I don't really care about using a protractor, so you don't have to do 13. All right, so just 1 through 12. And listen, guys, I'm just asking you to make sure that you're reviewing your notes about the proofs. All right, review your notes on the proofs. If you do that a little bit each day, if you go over 3 or 4 proofs every day, it'll be easy on Thursday. Any questions or concerns? All right. So bad.